Ladies and gentlemen, welcome to the March 2019 New York section meeting. I appreciate you all being here this evening. Tonight's topic will be archiving, on-prem, and cloud solutions for high-volume storage. We have to try the button. Okay. Well, maybe we're select that. There we go. Okay. Thank you. So, as usual, we started the evening by displaying the loop of logos. I think we're up to 47 sponsors now. We want to thank those companies, and we would like to ask you to patronize them and treat them as loyal supporters of the section, especially B&H Photo, who for the second year are our sustaining sponsor. By a show of hands, how many are members tonight? Thank you. And by a show of hands, how many are here for the first time? Ah, welcome. It's great to have you guys here. So if you're not familiar with SMPTE, please visit the website, become familiar. We've been doing this now, I think it's our 102nd year. That's the good news. The bad news is I started right at the beginning. So, it's about standards. And at the national level, it's about creating standards, and at the local level in the sections, it's about learning about those standards. And then in addition, it's about fraternity. It's about how we relate to one another as professionals, and also about how we help one another attain employment and so forth. So SMPTE is pretty much your community, and we encourage membership. Join, attend our conferences, our national conferences, our regional conferences. There's a number of ways to be a member, and this chart is on the website. You can review that. Thank you. Alrighty. Upcoming meetings, April we don't do a meeting because of NAB. May will be the annual NAB wrap-up. Tim and David will be once again producing, and we're very close to having a venue. We've been negotiating for a venue, so we'll have that announced fairly shortly. The following meeting will be at AT&T downtown on 33 Thomas Street. We had our June meeting there last year, if you recall. And the subject will be, once again, SMPTE 2110 and NMOS, NMOS. And at that meeting, we will have a live SMPTE 2110 system. Yeah, we're going to be doing a big demo there. So that's being produced by Wes Simpson, very knowledgeable on the topic, author and consultant on video over IP. So that'll be a great meeting. We look forward to seeing you there. Also, in June, that's when the Board of Managers chooses the topics for the following season, September through June of 1920. So if you have suggestions, if you would like to see your meeting topic, send it to me. Use that subject line, spell things just as they are there, and they'll go into a mailbox that I'm saving. And at the June and July meetings, we will vet those suggestions and come up with a program for the coming year. All right. At this time, I want to thank Rose Lockwood of Belden, who, with her colleague Eric Hirschberg of WABC-TV, have put together tonight's presentation. Also, we're testing our streaming for the first time in a long time tonight. Derek here from ABC has helped us put together a GoToWebinar streaming. We haven't announced the availability of that stream. We're just doing a test, but if this works well, we'll be streaming meetings going forward, so looking forward to that. So, Eric, if you would take over. Thank you very much.
Thanks, Jeff. Oh. Hi, everyone. I also want to take a moment to thank my co-producers, Rose Lockwood and Tom Murrow. They've been a tremendous help. This was my first meeting for SMPTE that I've produced, and a lot of this would not have happened without their help, and I think it's come together really well. I'd like to thank Derek, too, for his help with all the extra tech, and I'm looking forward to seeing how the streaming goes. I'd really like to thank all of you for coming. SMPTE does not exist without a strong membership, and I hope that many of the guests and first-time attendees see the value and choose to become full members. And mathematically, you make up for the dues with all the free food. So it is worth it. I especially have to thank Dolby Labs for the use of this great theater. It's a happy accident that we're here tonight. I was in a bit of a panic to find a venue, and somebody said, "What about the Dolby Theater?" And I immediately said, yes. Archives come in many forms, whether it's a museum vault of paintings or a diehard football fans' VHS copies of their favorite games. When NBC didn't want to use expensive tape stock for their daily talk show, its host, Johnny Carson, paid for the tape and paid to store it in a hollowed-out salt mine. And those shows are for sale now, and it's a steady stream of revenue for the Carson estate. For many broadcasters, the archive is still heavily videotape. It was considered unbelievable in 1956 when videotape recording debuted at NAB. CBS Engineering worked with Ampex to develop the breakthrough technology. A team of the best and brightest came together, including a 23-year-old engineer named Ray Dolby. Today, the media industry is all digital, and so is the archiving. Media companies work more and more in a file-based world, and this includes long-term storage. The possible solutions are seemingly endless, and often companies turn to experts in the field to guide them through the selection of procurement and installation process. One such expert is Brent Engel. Brent is the CTO of Synesys Oceania, where he manages a team of engineering support staff and data systems integrators. He realized early on that the ever-changing standards and formats require an expertise in workflow, networking, storage, and archiving of massive data files. With Brent's help, Synesys Oceania provides engineering services to support broadcast, post-production, visual effects, and film customers. I'm pleased to introduce Brent Engel.
How did you get that from the Johnny Carson estate? That's what I want to know.
It might be a later Tonight Show.
Okay.
Which one's yours? Sorry. Which one's yours?
That's it right there.
This one?
Yeah. That's it. How's everybody doing? Do I need the microphone or do I not need the microphone? Okay. Okay. So for my part of the presentation, I'm going to basically have kind of an open format Q&A, and I did that as Eric and I were talking, kind of prep for this. When we go in and visit with potential clients or existing clients on the subject of archiving, it just means something so different to everybody. We very rarely get the same answer. We have customers that simply archive because they have to, and they don't know what to do with this media that a lot of times has no value as soon as it's broadcast. That's especially true with our sports broadcast customers. They really do not like talking too much about archive. They don't like spending money on archive because the value of their footage just goes right off the cliff after the game is aired. With news environments, that footage has a lot of value. With people that are producing episodic television, has a lot of value. So what I'd like to do for my segment, since I'm talking more in general about the technology at large, I would like to kind of keep it open and do a Q&A and maybe get some input from you guys about, you have questions about archiving and what we do and how we approach it when we're basically coming in to talk to a customer. What do they do with all this massive amounts of digital stuff? You got to put it somewhere, or maybe you don't put it somewhere. Maybe you get rid of it. And sometimes our advice to customers is to get rid of a lot of it. You know, if you can't find a business reason to keep it, at some point you have to face that fact. So with that, how many people in here manage, deal with, or have something to do with the digital archive in their facility? It's about half. It's a lot of people. How many people were having to deal with it 5 or 6 years ago? Okay, it just dropped that in half. So I think probably I can ask the same question here 3 or 4 years from now, and it'll be just about everybody has their hand up because it's going to touch. So with that in mind, I guess I'm going to open it up to the room. How big are some of your archives? In terabytes or petabytes, if you know? How big are they? 100 terabytes. 10s of petabytes. Who else? So that's a pretty big range.
Personally, 100 terabytes.
Personally, yeah, because you have a lot of image that you have to archive. So when we go into a customer and or potential customer, we kind of come in and we try not to have, and I try to encourage my team to do this as well, we try not to make assumptions about their environment, and both the technical environment and the business environment. And we do that for a couple reasons. One, it will prevent us from having a true understanding of what their needs are. And the second is that it's not always, the customer is not always clear on what their archiving needs are, both from a technical standpoint and a business standpoint. And we tend a lot of times to have the inverse of a lot of other companies that are like us. A lot of times people want to come in and start talking about the technology, and we actually choose to do the opposite. We actually choose to talk about the business side first. Because if you can't build a business case, is there really a reason for us to sit in a room for days, weeks, months, for you to pay a consulting engagement, for us to spend all this time and energy on something that has no monetary value and there's no real business reason to do it? Does that make sense to everybody?
Not entirely. Sometimes there are cultural reasons to save things.
That's
The business reason isn't the only reason.
when I'm talking about the business reason, I'm not talking about just the money, but I'm talking about if it's a cultural value, then that means that they're basically going to have to make a business decision long term to preserve this. So I agree with that. A good example is the Carson example. But that preservation started off not being a monetary decision, but it turned out to be one later on. But we have a lot of customers where the preservation of their material, they simply don't have a way to deal with it. They don't have the funds. And we try not to make the cultural decisions, and I agree with you, but at the end of the day, it costs money to store this stuff. And somebody's got to pay the bill. And if you're going to preserve it culturally, then you may need an endowment set up to preserve that material. But you're still going to have to fund it in some kind of way.
I agree with you. I'm working with nonprofits who are involved in preservation, and they're nonprofits for that reason.
They've got endowments and donors.
There will never be a business case to
Yeah.
preserve this material.
And so after we build basically what could be a need for their business, and there's a way to preserve this footage, this audio, whatever the digital media happens to be, the next step for us is basically to start looking at their infrastructure and looking at the technology. And that's when we get into discussions about how are you going to use the archive. And we have people that use it for all different reasons. One case is what the gentleman back in the back mentioned, is simply long-term preservation of something that has cultural value. Another reason, a lot of times people just need it as part of their business continuity or their DR plan. Other times they know that this material has a lot of value and they want to be able to monetize it. They may not have a way to monetize it right now, but they realize that there's going to be a way to monetize it in the future. And then the other reason that we run into a lot, and we have a lot of non-broadcast traditional customers like banks, they have compliance reasons. So we have one of our largest non-broadcast customers is Walmart, and they store, they record more HD video than our largest broadcast client in a day. Because you add up all the stores they have worldwide with PTC cameras, all recording HD footage. So they preserve everything for different reasons. They preserve it for compliance reasons. There's a lot of reasons to archive things. Yeah.
Brent,
Yes.
are you finding more people going on-prem versus cloud, or
Where do you see the majority of those customers going?
It depends on the size of their archive. It depends on their existing infrastructure. How much do they have invested in on-prem? And a good example is we have a large sports league. We support their archive, and it's about between 50 and 60 petabytes right now. So we've done the math. We've looked at actually taking part of that to the cloud, and we sit in a room and we meet with the CFO, and basically we can't work a business. The business model's not there. Even with huge chunks, even with, in this particular case, with AWS basically giving us huge chunks for free, the cost of it is still, in that case, for archives that large, and the fact that they've already got two massive Oracle libraries, there's no affordable way to move that to the cloud right now. So in that case, it stays on-prem. But we have other customers that don't have that investment and have archives in the 10 petabyte and lower range, and it makes total sense to put that in the cloud versus building out a data center on-prem. And then we have customers that have a hybrid environment, which I'm sure the other speakers will get into some of that.
Do you find that people want to archive in a lesser algorithm to save bytes and so forth?
That does come up. In other words, it has different names, but yes, we have certain customers that are looking at a proxy archive. Basically what they're deciding to do, if they've got media asset management systems, they will just decide that we can't afford to keep the high-res material, but we want to be able to keep the data and the metadata, and they'll simply choose, make a decision to have just the proxy. Does that kind of answer your question?
Brett, how strong are these business models? Do people actually make money at them, or do they just pretty much break even but get to keep all their stuff?
Yes.
Could you give us some examples of some that are really successful that really make money?
We have a large news client that basically has a way to monetize and sells licensing to their content, and they make money with it. And then we have the opposite end of the spectrum. It would be the sports league that I mentioned. They are preserving it. They do use it some, like when a player dies, they have to go back into the archive. But I would say it's more for the cultural reasons and the preservation of the history of their league, right? So to the gentleman back in the back, it's more for those reasons. They can't really make a business case for it right now. They just know it's something they should do, and they know that they have to go to it from time to time and find things.
So have you come across challenges with any of your clients regarding archiving the associated static and dynamic metadata as well as the assets themselves?
Yes.
Are some of those metadata archives actually larger than the asset archives themselves?
I don't have any that we've architected where the metadata is larger, but I think as more people realize the importance of metadata, I could see that happening in certain places. It hasn't happened with us yet. It's not close, but we are, one of the things that moving to both the on-prem archive systems and the in the cloud systems are a lot smarter about how you can associate items. So object storage, whether it's on-prem, whether it's in the cloud, tape management systems, standard databasing, everybody's getting better about taking your metadata and storing that with the object so that it always stays together. And that's real important when you might want to reference something 50, 60 years from now. It's important that all that stays together. We did a project for NASA. I can talk about this customer because it was paid for by you, the taxpayers. We did a project at NASA where we actually used, as most of you know that have messed around with DPX frames, in a DPX frames, the SMPTE spec allows the front part of the frame, you can put user-defined data. So this is a long-term archive for NASA. So one of the things that they didn't want to have to deal with 40 years from now, 50 years from now, is trying to trace down the audio channels. A lot of this was test footage. A lot of it was footage going back to the Apollo program where you had multiple channels of audio. Some of this audio was not audio. It was measurement test data that was driven down an audio track. So it sounded like warbles to me. And but we basically had to put several old tape archive systems. We have 2 telecines. They've been converted to scanners now, and they're still bringing in. We did 9 million feet of film in about 7 years on this archive. And one of the cool things that we did was we did some custom software work where we basically embed the audio. We take the raw PCM data and we embed it in the header of every frame. So if you have 24 frames, that 24th second has 24 second of audio embedded in the frame. So that archive now, when you just play back that DPX, and then we made an open published statement of how it was embedded in there, so somebody can read a document and they can simply read that data back out of the header. So it's little things like that. It's a little thing, but it makes a big difference when somebody goes back to this archive 40, 50 years from now. So.
How long is the average person storing stuff before they lose rights to it?
Yeah, the gentleman's asking how long are people storing material before they lose the rights to it. I would say everywhere from instantaneous to never. So I don't mean it's not a pat answer, but we have sports broadcasters that ingest material. They have the right to have certain parts of it for the game, and as soon as that game is over, they have no rights to anything, and they're supposed to get rid of those pieces. We have other sports clients where if it's part of the league or the regional sports network, they have rights to it for their team. If they have interviews with the coach, if it doesn't have other players, they have those rights, and those rights extend in perpetuity. But and then we have other clients where they own all their content and their rights go. And I would say it's all in a mix. And it's a good question, though, because managing your archive means that you can't be putting stuff, or you shouldn't be putting things in the archive long term that you don't have rights to. And
We don't throw anything out.
Hey, just a question. You discussed that there, in some cases, isn't a business model to be generated to support the preservation of the material.
Yes.
I might submit, in my experience, that's because we lack creative business people to come up with those ideas. And my evidence for that would be YouTube and the fact that people monetize the hell out of the stupidest crap anyone could ever imagine. And it doesn't have to do with whether you're a nonprofit and, or it's, hundreds of thousands or millions of hours of sports footage. We're talking about the classic long tail of media that people have talked about for 25 years.
I agree with you. And the beautiful thing about my job and being a nerd for a living and managing a team of nerds is I can tell them how much it's going to cost. And if they want to do a certain thing, I can tell them what the initial CapEx is going to be, what the OpEx is, or if they're going to go all OpEx. But I agree with you. I can't make for the partners that we work with those kind of decisions. I can only advise them. But to your point, we have a lot of companies that the archiving is just one big, huge expense, and they're basically keeping that material because they don't know what they don't know, and they're just afraid to get rid of the stuff because of your reason. Maybe in 10 years, this stuff's going to be worth millions and millions of dollars.
Is there a point of no return on storage space?
I don't know what you mean.
Like how much space does someone, if someone's basically storing, I guess, a few petabytes, and suddenly they have a couple hundred petabytes, are they adapting to the cost of the future petabytes, etc.? And how much to maintain them?
I would say most of the customers that we work with are only go out on their OpEx and CapEx plans generally about 5 years. So is that enough time to really manage the cost of this? I would probably say it's not. But given the business constraints that we're in, that's pretty much the limit of CapEx and OpEx plans that we're working with people on, at least telling them what it's going to cost going out.
Brent?
Yes.
For the on-premises archives that you're involved with, what do you recommend in terms of backup strategies for that material?
Do you mean as far as policies, or do you mean you're talking about the hardware or the software? Tell me, help narrow it down.
Fathering and grandfathering, how many backups do you recommend? Off-site backups? What's your general advice for on-premise archiving?
So
there is some backing up going on, I presume.
That's a good question. We stay out of we have a few clients where we actually do some backups, but most of what we do is on the archiving side. And it's a lot of times, I know there's a lot of overlap, and it's hard to get people to always understand the difference between backup and archive. And we do have people where they cross it and they use their archive as a backup. And then we have also people that basically, we've put in some on-prem, both tape and object storage, and with hybrid to the cloud, where they just decided that they're going to back up everything. So it becomes their archive and backup all in one. And what we basically do every night, any new or change data gets put in that backup archive, whatever you want to call it. And in that case, I would say they're kind of covering their bases everywhere. And what they're doing there in those cases, to answer your question, is we basically have 2 copies, because if they ever have somebody have ransomware or something like that on valuable footage, what we do is odd and even days. So we set a policy that this partial backup or archive for all of their SANS and NAS systems for the odd number days, this one goes on Monday, this one goes on Tuesday. So they've always got back a 48-hour period. If something happened, they could go back in time. That's about the extent that we get in that. If you get into more granular backup where you're doing servers, you're talking to more traditional IT, and we're IT for broadcast. We really don't get into that side of the business. There's plenty of IT companies that are good at that piece.
So, Brent, automated metadata extraction is starting to become very powerful and feasible. So do you think we are at a price point for those kinds of services where your customers are actively looking to pull content out of the archives in order to extract the metadata so it's more searchable and discoverable?
We already have customers doing that, and it's actually quite successful as long as it's not the only system. We're not there on using AI. It doesn't give you the kind of percentage hit you need to have it be reliable, but what we are using it for is to augment metadata. So that if you do use an AI process and you scan your archive in the background, you build up this very large metadata library that you can search against. You can do standard Google type searches, and all that metadata was just harvested programmatically through an AI algorithm. You can do it both for dialogue, you can do it for images. That exists right now. It takes a lot of processing power. You can use the cloud. This is one of the advantages if you have your archive in the cloud. You can basically leverage that AI, but we're also starting to get AI engines that are on-prem where we can simply build a large GPU cluster and you can license that as a site license and you can do it on-prem. So it exists in both places and people are using it. I would just say people that want to put all their eggs in one basket, I would say it's a tool and it's useful for giving you additional information, but it's not an end-all be-all. Not yet. For most customers, no. If you have high-value archives and the metadata and you need to find things really quickly, then yes. So I think I'm being told my time is up. So I'll be around later for any more Q&A, and I'll hang out and try to answer questions. Thank you, guys.
Okay.
Hopefully.
Thanks, Brent. And actually, we are going to have a full Q&A session with all 3 presenters after the next 2 presentations. So, thanks for your patience. And I'm going to need that. Okay. So next up is Imran Ahmed. I hope I got that right. He is a senior pre-sales systems engineer at Comprise, an industry leader in intelligent data management. They specialize in automated cold data migration to cloud storage. He is a graduate of the New York University Tandon School of Engineering, and he's worked on cutting-edge cloud and data center optimization solutions for over 10 years. Please give a warm welcome to Imran Ahmed.
Thank you very much. All right, thank you for that kind introduction.
Pointer present.
Yeah, thank you. Okay, so I actually have a question for everyone. How many people here deal with the challenge of unstructured data growth, rapid data growth? By a show of hands. Okay, it's a good number. All right, so that's what we're going to talk about today. We'll talk about a couple ways to address that as well. Let me see if I can. Okay. So, industry analysts are saying by the year 2025, we will generate 143 zettabytes of data. I actually didn't know what a zettabyte was until a few months ago, and it's 143 million petabytes. That's a ton of data. So what's actually causing that? So there's a number of things that we see contributing to data growth. And you're probably familiar with a lot of these. So medical imaging, right? You see the high-res technology that's available today in this industry. Genomics research is very big. IoT sensor data. So you know about the Internet of Things. Cars have a bunch of sensors now. They're self-driving. We have, your doorbells. You've got video feeds from your Ring doorbell or whatever it may be. Social media is huge, generating a lot of data. I think the next two are more relevant to this group, right? So improvement in camera sensors on mobile devices. When you snap a picture, they're getting bigger and bigger, right? Every time there's a next generation iPhone, for example, the photos that are produced are much larger, and you're storing them somewhere, or we're storing them somewhere. And then we have higher res video and audio formats, 4K, 8K, and so on. So files are just getting bigger, and we have more and more data. If you've been looking at analytics, AI, machine learning, there's a whole ton of data that organizations want to keep around longer so they can kind of glean more information from. So that's also causing a lot of data growth. And so what's the challenge here on the IT side of the house? Data is exploding, but the budgets remain about the same year over year. They're not really growing much. A lot of the NAS systems that we use, like Isilon, NetApp, and so on, they're very expensive to purchase, to maintain, to expand over time. They're very expensive, right? And we have to back up this data that we're housing on primary NAS. So we've got to protect it. And we have all this cold data that's sitting out there that not many people are using that we're backing up over and over. So that's also costing us in terms of resources and time. And most of the data is not being used actively. So there's kind of a mismatch where stale data is sitting on high performance or performant storage. So one of the solutions that I think a lot of people in the industry are seeing is let's use object storage to house this cold data. That's not really high velocity data. It's kind of stale. Instead of putting it on primary storage, let's put it on object storage. Object storage is really cost effective. You can get it on-prem or in the cloud. It's also very scalable. You can scale. I mean, there's really no limits if you think about it. You can go hundreds of petabytes or more. And you can have billions and trillions of objects too, which is beyond the scale of traditional NAS systems. And there's also built-in resiliency. So a lot of folks, when they move to object storage, they don't need to back up that data anymore because it's stored in triplicate or it's dispersed across multiple regions. They've got erasure coding and replication, so there's really not a need to continue to back that up. So it actually eliminates the need for data protection. So who are some of the players? This is just a small list, and there's so many out there. We've got cloud providers like AWS, Google, Azure, IBM, Wasabi, and there's a number of on-prem object storage system providers as well. Just want to give you a flavor for that. Okay, so here's the challenge with moving data to object storage. How do we figure out what data we want to move? We don't really have tools that allow us to, classify the data and allow us to make decisions on what data to move over. It's really difficult to just get a team of people to figure that out. You really want a software-based solution to do this for you. The other challenge is we don't want to have a rip and replace approach where we disrupt users and applications where their data is no longer on-prem and they can't access that data that's been archived. We kind of want to fit seamlessly into their existing architecture. So we don't want to disrupt what's happening today. So that's another big challenge that comes with moving to object storage. So that's where an archival tool can help address these challenges. So what do we want to look for in kind of a next-gen, intelligent archival, data archival tool? So we want to be able to use any share that's standards-based like NFS, SMB, CIFS. So we want to be able to talk to any share, analyze it, figure out what's sitting there, classify the data, understand how old it is or how fresh it is, and then be able to make decisions with that information. So we want to talk to any source. We don't want to sit in the data path when it comes to the hot data. because we don't want to slow down the environment. We don't want to become like a choke point. So any solution that we select, we want to make sure it's not in the hot data path. It's also got to be able to scan environments very quickly, because if it takes months to scan billions of files, you're not going to get to archive, behind the scenes on an ongoing basis. It's going to be very difficult to archive, because by the time you finish scanning it, things might have changed. So you want to be able to scan really quickly these multi-billion file environments. Also, we want to ideally use symbolic links for transparent access. What this means is, if we archive a file, we want to leave a symbolic link, which is part of these NFS SMB protocols, which means that the users or applications that are wanting to open any old files, in that rare occasion, they can still do that. It looks like the file is there because there's a symbolic link in place, and they can still open those files even though they've been moved elsewhere. So that allows for this transparent access that's kind of invisible to the user. We also want the archive solution to be resilient, because if we want to make sure that the data is always available. So the solution should be resilient and be able to accommodate, a particular node going offline. It should be able to kind of self-heal and recover. We also want to be able to write to a number of targets, vendor agnostic, so that in the future, if we decide to change anything, it's supported. Also, if we archive data, we should also have the option, ideally, to be able to access the data on the target as well. Even though it's accessible from the source, what if we want to, share this data with another organization from the bucket itself, from the archive tier? So that's an important feature as well. Another one might be, I didn't actually put this on here, is the ability to migrate data. So if you've archived a share in the future, you want to move to a new platform, a new NAS, the ability to migrate that share while preserving that link, that's also very important. So that's what we're going to look for. Here's kind of a picture of what an ideal architecture might look like. So you have your source NAS system. That's where you have all your files today. That's your production primary NAS. You have your users and applications accessing the data. And on the side, you have your data archive software. And this is going to analyze all the files that are sitting on your NAS system. And it's going to figure out, how old the data is, what data is 3 years old, 2 years old, and so on. And then you'll be able to pick, which data sets you want to move over. So once you've decided what data you want to move, it's got to be able to encrypt that data and send it to your target location, whether it's in the cloud or on-prem. So it's going to move the cold data, it's going to encrypt it in flight, and send it to the target location. And you'll probably have like a GUI interface to manage this software, and that's going to also provide you with your reporting and analytics and allow you to design your archive plans. So that's kind of an ideal architecture. And let's look at this in a little bit more detail. This is your workflow. This is kind of how you want to see this behave, is with hot data, the users are going to continue to access their hot data as normal. There's not going to be any change in the data flow for active data. So this archival software is going to sit to the side. It's not going to be involved in the access of active data or hot data. When it comes to colder data that's been archived, this is where you want the archival system to handle that. So what's going to happen is a user or application requests a file that they see on the source on the NAS system, and what the symbolic link is going to tell the user's machine or the application to go to another location automatically. That's what the symlink is going to provide. So the archival software solution is going to see this request for a file. It's going to know where to get it from. It's going to retrieve that file from the target location, whether it's on-prem or in the cloud. And it's going to service that file directly to the user. So it's going to be another quick hop. Instead of getting that file directly from the source, it's cold data, it's been archived. The software is going to pull it from the target, retrieve it, and deliver it to that user or application. So this is the cold data path. And again, it's fully transparent to the end user. So what the result is, we can do archival without users really even knowing about it behind the scenes, right? So here's kind of a screenshot of what this might look like for a kind of I guess a user share. They have their files. This is before archival. After they archive, they still see the files, and they can still open them. They'll just be stored in the archive, and they'll still be able to open them without any extra steps involved. Now, a couple things to mention. If it's in the cloud, there may be a slight latency in retrieving the file. Really depends on your WAN connection. If it's on-prem, it's probably not noticeable. So what are the benefits of doing this? It's number one, it's really the cost savings of not storing all of this cold data on the primary NAS system. So this is kind of typical of what we see customers or organizations doing today, business as usual. All the hot data, all the cold data is on the same system. And it's not really their fault. They just don't have the tools to kind of move that cold data transparently away from this primary NAS solution. They don't have a tool to figure out what's cold, what's hot. They don't have a tool to automate the process of archival. You can ask users to archive cold data, but rarely does anyone ever do that. So with a tool like an archive tool, you're going to be able to really save on this, number one, the storage capacity, right? You're going to be able to drain that cold data off your primary NAS, right, and free it up for new data growth, and also see a lot of backup savings, because on the backup side, you're not having to back up this cold data during every backup cycle and pay for backup licenses, pay for backup hardware, and so on, in addition to the NAS hardware. So, why is this important to us? We have a customer example here where they were able to reduce their NAS costs by over 50%, reduce backup times by 60%. So your backup windows might be going from days to hours. They're able free up the NAS system for new data, for that growth, not disrupt the existing users and applications, and this has a really big return for the investment in the archival solution. Just threw some numbers up there in terms of how much they actually saved, but again, it's going to vary depending on what you pay for storage and backup, of course. So this is really important. I think this is probably the last slide, yes. And we are going to be at NAB next month. I know there is an SMPTE meeting next month, but if you want to meet us, we will be at NAB as well in Vegas. Is that right? Okay. All right. We'll talk to you guys later then. Thank you.
Thank you. Yep. Great. Thanks. Okay. Great. So, finally tonight, before the Q&A, don't jump up just yet, will be Mike Palmer. Mike is the CTO of MassTech, responsible for overseeing the company's technical strategies and developments. Previously, Mike played a role in driving the development of the first media asset management system to deliver drag-and-drop inter-site sharing for news content between different production systems. All of this from the newsroom desktop interface. This award-winning innovation gives journalists rapid access to content shared both locally or at any facility in their group. Mike is an active contributor to SMPTE standards, including the Archive Exchange Format, or AXF. Mike has received Broadcasting and Cable's Technology Leadership Award for his impact on technical standards, and he's brought his expertise to share with us tonight. Please join me in welcoming Mike Palmer.
Thank you. So I have two hats firmly on tonight. I'll put the first one on. That's the SMPTE hat. And first I want to acknowledge the other folks that work on the AXF group. It's led by Merrill Weiss, and then James Snyder of the Library of Congress, Brian Campanati, and Dave Dilo of Sony are also regular contributors. So we'll go and we'll talk about AXF Part 1, which some of you might have heard about. AXF Part 2 is in draft. You probably haven't heard about that one. And then we'll get into how that might apply to actual strategies for archiving. AXF stands for Archive Exchange Format. Okay? So it was first published in 2014. It was updated in 2017. Its reason for being is basically to resist entropy while storing and transferring content. So this is meant as a wrapper and a container for long-term storage. And whenever we say long-term, James Snyder, Library of Congress, thinks about storing something for the person who will sit in his chairs 100 years from now. Okay, so you really start thinking about 100 years from now, will somebody still have the spec for JPEG? Will they? So these are things that he thinks about. It's meant to keep the media and metadata together. Information science says that once you start separating things, it becomes easier to lose them. I think that's pretty intuitive, but it can actually be measured. And then also enable wide exchange of content between content producers so that there is a standard for doing that. It's meant to be storage technology independent, to write to media of any type, and to flexibly include any metadata. When we say any metadata, it's just not closed caption files or something like that. We're talking Excel spreadsheets and Word documents and PDFs as well. The Part 1 objectives, again, enable movement of material between different systems, provide flexibility in changing archive management vendors. This is a key one here that's coming up. In 2014, when Merrill started working on this, this was one of the objectives, and that was to make sure that you could switch your MAM and PAM vendor without having media lock-in, and we'll get into why that's important later on. Protect the archive investment, and also support for metadata that enables automation. So think of AXF Part 1 as being a zip file on steroids. Okay, so it has a compact file system of its own, so you can actually arrange files in a hierarchy within the wrapper itself. It does support compression. It also supports encryption, and it can contain and associate files of any combination in any hierarchical fashion. It supports hashes, optional redundancy, and optional error correction as well. It is not tied to LTO, but it is designed to work with LTO, LTFS, as well as other types of storage. So what do we mean by that? You can generate an AXF file that you can then put on any storage mechanism. Okay? Or, if you want, you can write to a streaming device such as LTO or LTFS and put additional redundant information in there so that it works well in a streaming format. So, again, the practicality of AXF for the archive is it takes the 100+ year view. It's a self-described format. In the example that we had earlier working for NASA and capturing some film content with audio in the data channels, creating a document that then has to move with that into the archive. If you took that document and put it inside of the AXF wrapper, then everything is wrapped up together and it can't be disassociated at that point. Somebody finding it from the file 100 years from now would be able to use everything within that file without having to look for an external document. It is self-described. It is meant for preservation and reconstruction, but there are also other uses for it, and we'll get there in a minute. Another view is for the media manager, now in 5-year short term. It means reduction in storage cost. So let's say that you're storing DPX files. If you're storing DPX files and trying to put them directly into an object store, you might tend to, unless you wrap them up, write each individual DPX frame as an object. Okay? And when you start writing that many files into the cloud, your transaction cost goes way, 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 way up. If you have the ability within AXF to actually wrap those into a single container, then you lose those individual transaction costs and your storage costs go down. The metadata is stored in a wrapper. Another example is news archiving. You can take the script from the newsroom system and drop it directly into the same container, and you have both the metadata and the media in that same file. And again, MAM and PAM independence. I'll get to that in just a second. AXF is integrally compatible with IMF and DPP. People keep saying, well, I thought IMF is the be-all to end-all for playback. Well, it is. But if you put that inside of an AXF file, you could also associate the Cinema Productions script and the Excel spreadsheets and all the business data that went along with that program as well. So they are very complementary. Okay, AXF Part 2 is something you probably haven't heard about, and it's in the working group right now. Its reason for living is it is a recipe for Part 1. Let's say that you're producing an episodic program with special effects. You're shooting that content in multiple locations, possibly on multiple continents. You're also using multiple special effects companies to produce that. As that production starts coming together, those individual elements are actually located not only in just different storage locations, but in different geographic locations. Okay, this part 1 is actually a list of pointers and metadata pointing to where this content is. Okay, your special effects are in cloud A. Your raw for this particular scene is in this storage on in Australia. Your storage for another scene over here is actually in Europe somewhere on a different object store. This gives you a single a document file in which you can put all the pointers and the metadata. Now, not only is that a recipe then for creating your AXF1 part file, because you can actually pull all the content from the pointers and create your file from that, but it's also something that's very handy to pass around the production process. So if somebody wants to go and cut a trailer, you can simply give them this description and they have access to everything. They know where everything is at that point. It's intended to be lightweight but complex container metadata, pointers, and files, and you can use it to create the part 1. So with the lifecycle focus, it's used to keep track of the raw material, like we said before, and they can be retrieved and linked, and I think we covered all that. Now, I'm going to take the SMPTE hat off, and I'm going to put the Mastech hat on at this point, and we'll talk about how some of this can actually apply to archiving. So on-prem, private cloud, public cloud, or hybrid, which one is best? It all depends on the customer, what they need, and what their workflow is. Okay, so nothing is irrelevant. No storage technology is irrelevant today. But we need to think differently. Lift and shift may not provide equivalent performance or cost in the cloud. So if I have on-prem storage right now and I try to take that same workflow that's connected to the on-prem storage and move it into the cloud, it's not going to behave the same way. The cloud has different benefits and attributes, and just a literal lift and shift often does not work well. So cloud is different. Think differently with it. Take advantage of its advantages. Something really important here is this: your data will never stay in the same place forever. If it did, it would die. Change is constant. Okay? How many people remember zip drives? Okay? How many people still have a zip drive? How many people checked it lately? If your zip drive died today, who would you take it to for repair? Is anybody selling replacements? Okay? So if you have content on a zip drive, it probably makes sense to move it off as soon as possible to something else that's going to be supported for a little bit longer time. And that's, I'll get into it in a minute. That's actually a big problem with LTO right now. Next generation systems should be able to manage complex hybrid clouds to provide seamless user experience and optimize cost, performance, and availability. That's because you're going to have to spread your content across multiple clouds and storage technologies so that you're able to take advantage of the benefits that that particular thing is going to provide. Not all clouds are built the same. So hybrid cloud storage. The first definition of a hybrid cloud is simultaneous use of multiple cloud storage solutions. Kind of counterintuitive according to most marketing right now. Most people first think that hybrid cloud means a combination of on-prem and off-prem. Actually, the first definition is multiple cloud storage providers being used together. The second one is use of on-prem and off. Then what we term complex hybrid cloud storage, and that is multiple on-prem storage locations with multiple cloud storage locations at the same time. Okay? And this is really, if you don't think you're headed in that direction, okay, write it down, come back and see me in 18 months, okay, because you're going to have at least your toe dipped into that. So here's some examples right now of contrasting storage costs for on-prem storage and a cloud storage solution. So we're talking about a generic 48-slot LTO library, pretty standard for mid-market television stations, okay? And then we're also looking at a cloud, and we're looking at a 0.3 cent cloud, a 5 cent cloud, and a 7 cent cloud. Whenever I originally created this slide 18 to 24 months ago, 7 cents was where cloud storage was, and I anticipated it dropping down to this point. This is about where we are right now. It's going to take us a little bit longer to get down to 0.3, okay, but at least you know what the spread is. Here we're talking about an entertainment channel, greenfield, ingress of 50 megabits per second, 60 minutes of content, 6 hours per day. There's no egress at this point. I'll show you, the next slide will show you what the egress cost on it. And this is LTO migration. We're going to migrate from LTO 7 to 9 in 5 years. That means replacing the drives and all the tapes. That's what this jump here is here in cost. That's your migration cost. Okay? So compare that now to including egress. So if you're using it for playback, I'll jump back and forth between these two. Okay, suddenly the cloud costs go way up above what your on-prem storage costs would be. Okay, and I'm not preaching one storage technology over another here. Different customers have different needs, but just be aware of this. So here's an example for a news archive. We're talking going to a location. There's 4 years of legacy content. It's all in whoops, gave that one away. It's all in 35 megabit format, 90-second average duration of each asset, 150 assets per day. The interesting thing about news archives is they expand all the time. Okay, you're constantly adding content. So if I add 1 unit of content a month, in January, how many units do I pay for? Okay, in February, how many units do I pay for? Okay, do the math on that. It becomes very expensive over time. It scales in this type of fashion. We're only reading about 30 assets a day because we only read a small amount from our news archives. LTO migration from 7 to 8 year 3, that's what this jump is. Okay. Now, let's see what happens if I drop that from 35 megabits to 8 megabits distribution. This is the same bit rate that you're getting from your networks whenever you ask for content from the network. Okay, so your journalists probably aren't going to notice the difference on this. But look how much longer you can stay under the on-prem cost if you're putting it in the cloud at distribution bit rates. Okay, so this again is knocking the bit rate down before you move it up into the cloud. Now, if you have a system that can intelligently manage this, you can keep 2 months, 3 months, a year's worth of content on-prem uncompressed at 35 megabits. So you have a constant amount of that on-prem, but everything else you're moving into the cloud at this, and you get dramatic savings. Yes?
Mike, you say on the cloud, in the cloud, but we all know that the cloud is really just another storage facility. So there is hardware at the cloud.
Mm-hmm.
Still seeing that cost.
Well, this here, you're paying somebody else to manage that hardware for you, and they're selling it as a service. So you aren't factoring in power, air conditioning, staff to maintain this, and doing your own LTO migrations and other things at that point. Okay? So the key here is reduce your cloud storage to the minimum possible, and you'll actually get the most out of the cloud. If you push a lot of stuff into the cloud, you're going to pay more for it. Okay? So, currently we have an overdependence on databases when we do archiving, okay? Even when we're using object storage, because, again, we'll just take an example of news archiving. We're storing the script and other metadata from the script, the rundown, etc., in a database. We're storing the media in storage. Let's say that the database goes away. You are screwed, okay? You've lost all your pointers to your media in your tape library or an object store in the cloud. That's a bad thing. You can have the individual files, but they are worth nothing if you don't have the story title, the date, and the script that goes behind them. Am I correct?
Yeah, but why
Okay.
would you lose your database? That's like the first thing you back up.
Let's follow this, okay? Let's say you switch vendors, okay? Your vendor's using proprietary format for that database at this point, okay? They're still doing it. How many people have done an archive migration from one vendor to another? Is that always an easy process?
Not when the account's done,
It can be difficult, okay? The point here is that if you write the metadata into the storage, as we said earlier, you're giving yourself a much better ability, a much easier task of switching vendors because your metadata is not being held hostage in their database. Okay. We're switching to this format. That's our NAB message. And we're doing it exactly that for that reason, so that customers are not held hostage. And let's see. Object storage by itself. Let's look at the definition of object storage. I give you a file, you give me a token. Okay? I come back to you and I give you the token, you give me the file back. Okay? There's no definition of metadata being stored with that object. Okay? Storing metadata in object storage is an optional thing, and it differs from vendor to vendor how much space you get to store the metadata with it. Okay, with AWS you get a certain amount, with Azure you get a certain amount, but it's not the type of metadata that you can do transcripts and long descriptions of content. It's better if you go to actually wrapping those in something like an AXF format. Then you can store it all inside of object storage at that point. So, combination of AXF and complex hybrid storage, it gives you the flexibility to move content to the optimal storage at the right time. So it's lifecycle management on steroids. So you're looking at multiple storage locations, and you're not only looking at the attributes of your content, but you're also looking at the attributes of the storage, so you can move the right content to the right storage at the right time. Sometimes Azure is the right place, sometimes Wasabi is the right place, sometimes your on-prem storage is the right place. So the last examples here, and these are slides I just put together today. Let's imagine a news archive, 35 megabits, again the 48 slot library. We've now moved on, we're at LTO 8 right now. Okay, we can imagine LTO 9 coming out in a couple of years. We're going to bring in 10 years of existing content. We're going to put in 4 years of content before we do another migration, and we're going to keep that for 10 years. Okay, so here's our LTO migration at that point. 103 stories a day, 1.2 minutes, 35 megabits per second. At the end of this 24-year time, using LTO 9 ultimately, we're only going to be using 23% of that 48 slot library. Think about that. That 48 slot library can hold 105 years of your content that you produce on a daily basis. Your initial investment is going to be around 40 grand. If you're going to put it into the cloud, you're going to start off paying 9 grand a month, and you're going to end up paying 16 grand a month. Okay? If you take the total amount of storage and then divide it by the total amount you've put into each one of these, your LTO is going to be about this, less than half a cent per gigabyte over 14 years. Here, AWS here is going to be 0.63 cents per gigabyte over 14 years. Okay? So this gives you the breakout up there. Here, let's look at knocking it down to distribution bit rate at 8 megabits. You see the same type of thing, but look at this. It's actually more expensive to keep it at LTO at this point. Why? Because you're only using 5% of the library, and at 8 megabits per second, your 48 slot library can contain 461 years worth of content. Yes?
Do you expect Amazon Web Services to charge the same amount per terabyte in 14 years as they do today?
Good point. And no, I don't, but I couldn't include it in the model, but thanks for taking it out. But even if they did bring it down to 3 cents or 2 cents, they can't charge nothing for it. Okay? And basically, whenever you're paying Amazon to store that stuff in the cloud, you are paying them to use the same technology you would otherwise be using on premise. Okay? So the cost curves are going to follow each other, but the limitations, they're still going to be building in the cost of doing business in there, so there will still be, the two cost models will still continue to diverge. And there we go.
We're just going to jump to the questions for a minute. Okay, great. Thanks, Mike. Come right over here. Imran, can you come back down? And Brent, did we lose? Oh, yes. And got a couple extra. Is it on? Here you go. Make it easy, have you guys know.
get the other? Did we lose Jeff?
We're good. I think we're good. We had another microphone.
I'm here. Did you have a question? Oh, yes.
This is a question from Mike, and putting back on his SMPTE hat and talking about Library of Congress and AXF. Can you point out an open source piece of software that can write and read to AXF?
No. To my knowledge, it doesn't exist.
That's the problem of a long-term archive.
The spec exists, and people have written clean room readers and writers, small in form, that you can go and purchase. We're looking at ways to try and get that licensed, and so it can be distributed freely. So you can basically have an AXF Explorer. So if you have an AXF standalone file, you'll be able to open up much like a zip file explorer would be. But we're still looking at ways to either develop or license that.
Thank you.
If you're looking for AXF to sustain an archive over a 100-year period, and you're talking about putting PDFs in it and spreadsheets, and what do you do when Microsoft has been out of business for 25 years and Intel has no longer been making chips for the last 15, and you can't support any of that anymore?
James Snyder has a really good response to this that I can only approximate. Okay, but within AXF, you have the ability to not only include links to standards, okay, but also the ability to put pseudocode in. So if you wanted to put even down to the level of describing DCT in pseudocode, you could do that and put it inside the AXF standard. So that's what we mean by being self-describing. And there is complexity in writing that, but basically you're creating a Rosetta Stone to put at the head of your file in these in the fields that describe the content so that people can decode those at a later time.
Mike, you had a slide where a news organization was using 23% of a 48-slot library. Who's making a 12-slot library? Because that's much more appealing to them than a 48-slot, even with the cost projection that you had there.
Right. There are smaller libraries than 48 slots that you can buy, but I'll caution you about this. As we start to put so much content on a single piece of media, the implications of a failure in that media, even if you're doing backup, is pretty great. Right now with LTO 5, 6, and even 7, you're not putting an entire year's worth of content on a single LTO tape if you're writing it at 35 megabits. So if I lose a single LTO tape, if I haven't been diversifying it and writing it across different tapes, I haven't lost an entire year's worth of content. Once you go to LTO 8 and 9, and if you're going to distribution bitrate, you're putting years of content on a single tape unless you stripe that across multiple pieces of media. And that's actually something we're working to do and bring to a later release.
A quick question, just looking at AFX. Does that give you the ability, in theory, to add in a blockchain component so that then you have a secure mechanism for sharing across the supply chain?
You can put any type of file inside of AXF. So if you can express a blockchain transaction as a file, then you can put that inside of AXF.
Question for Brent. What tools do you usually use, I mean, in these really multi-petabyte environments that you spoke of before? How do you identify cold data or data that's candidate for the archive? And then how do you automatically move it, or is it a manual process?
It depends. Generally, the first thing that we do once there's an engagement and we realize we've decided to tackle the problem, is we have some tools that we use, and the first thing we do is we scan the entire environment. We have a piece of software that we use as a diagnostic tool, and we basically will scan petabytes and petabytes. And what that does is that gives us something that we can look at very quickly. It has an in-memory database that's specifically around file system data. So it allows us to basically look at all the millions, billions of files they have on this NAS, this NAS, this SAN, and once we get an image of that, what we use basically, we can look for commonalities. If people over the years have had some sort of discipline about where they put things, then we can get more useful information out, and we can start to set policies around that, and we can automate some of those things. If it's completely unstructured data, and by unstructured I mean that you can't link anything, there's no likes to be linked to other likes, then we basically have to just organize things by date and by the size. But we have all that, and we can set the policy. We don't have to go out and walk down trees again through directory trees. We can use that tool to automate some of that just based on the date of the files, based on the type of the files, based on the file extension. So we can glean a lot of information from that tool. Does that answer your question?
The more metadata that you can associate with the file in the storage, the greater control you'll ultimately have over the management and control of the cost of that storage. Yes. And so for MAM and PAM vendors, if you can encourage them to write as much metadata down into the storage as possible, it's going to make storing that content much easier in the future.
It does. And also, it's also important to note that when people talk about metadata, a lot of times people are just thinking about this arbitrary data that's either in a sidecar file or in a database somewhere. But what we look at is if people have had some sort of organization in how they put data in directory structures, some organization around nomenclature, around their file system nomenclature, we can basically use that. That is metadata in itself. So we treat where they have put things historically. You know, sometimes this is 10, 15 years of data, and how they've named things. We can glean a lot of metadata, to your point, just on the file structure if people have had organization. But we also have customers where it's the Wild West, and it's like, I can tell you how many files you have. I can tell you how many files you have with this extension, how old it is. Aside from that, that's about it. It's, you know, you're really limited. And then in that case, it's a lot of manual. Basically, you're going to have some media managers busy for a few years.
Topic of the day is on-premise and cloud storage. And I think 5 years ago, we probably wouldn't be talking about cloud that much as we're talking about right now. With the explosion of cloud technologies and how, you know, with the factor that they're getting more and more sophisticated, would you foresee a scenario when all of the production from the start to the end remains in the cloud, and how soon?
I can certainly see that for some customers. For some customers, they will also have a need to do all of their production on-prem. I think that you're going to see a lot more customers going into the cloud. I can't guess what that split is going to be at this point, but I don't believe that everything is going to move.
Do you guys have tools for deduplication and stuff like that that you have to also deploy along with these scans when you get started with a new client?
It's a question directed to me.
I guess it would be sort of to everybody, but you seem to be top of the line on analyzing files.
Well, I'm definitely, we're always trying to solve problems. We typically, and you may have a different use case because you have other clients probably than just broadcast or media. But for us, since we're focused mostly in the rich media space, we don't find any sort of long-term value in deduplication because most of our customers are using very dense data, meaning that it's compressed video. And the standards behind and what people can get out of compression in this day and age, we don't get a lot of bang for the buck even talking about deduplication. So I think that is not the case for my friends on the IT side and for other types of data forms where they get huge advances of deduplication. So I'll answer it for my specific, because I'm narrowly focused on the broadcast and media space, but I'm going to let you.
In a news environment, we will look at source media, and if it's been used multiple times in a single day, we'll only archive the media once, but we'll archive every instance of metadata for each story along with that one piece of media. We now also have the ability of looking at the file hashes across the entire library and giving the customer the option to deduplicate it the next time that they do a consolidation in the library or a migration to a different technology. Oftentimes, once it's in the library, it takes more effort to deduplicate from that.
The payback.
Exactly. So you basically take note of that and then wait till the next migration change and pull the duplicates out at that point.
And with that, I'll add on some of the things that you can do with raw disk storage. We're at the point as just as an engineering, as a technology partner, and we partner with a lot of companies. We kind of, as a general rule, refrain from advising customers in this day and age to do any sort of data manipulations or creative things where you basically have operations that are pointing to raw hard drives and doing things where they're simply pointing to inodes, meaning any sort of variations in acrobatics around hard linking and things like that. We kind of discourage that in this day and age because it leads to your point earlier about having long-term preservation. How are you going to reference inodes if you're doing all sorts of trickery with that? At some point, you need to actually have your data as the data or in a wrapper, as you described earlier.
Can I add just one quick thing on the comprise side? The analytics we provide, we will be showing you, suspect duplicate files. So if you want to just kind of see what's potentially duplicate out there, Comprise is able to show you a list of files that could be duplicates.
I just want to agree with that and the importance of having the analytics, because most everybody's archives that are out there right now, people don't know how much they have, how much they've spent on them so far, how much they've made on them, where the hot spots of the archive that they're making money are, where the dead spots are, where they should be basically spending their money on storage and performance. It also makes it a lot easier to justify additional archive resources if you can actually demonstrate some ROI. And unless you have the analytics on top of that, that makes it difficult to do.
That's why we start with a scan, and it's always amazing that when we get the results of that back, we have a lot of people that are thinking, well, no, we do a really good job. We don't have duplicate files. And we show them that you've got 400 terabytes of duplicate data here. So it's just it gets really quiet, and they've hired us, but I kind of want to sneak away. It's like, okay, you guys need to deal with this internally. I'll come back tomorrow.
This question is actually for the group, so I want to step back a bit and say that I assume for the most part, NAS, storage systems are still based upon spinning disk, and they're still based upon a RAID structure of redundancy of data. I'm dealing with institutions that require the absolute integrity of the file in its state. Usually, sometimes when RAIDs rebuild, drives fail, RAIDs rebuild. Sometimes the state of a file changes. What type of systems or methodologies do you use to ensure that the integrity of the file is the same, not just the integrity of the storage is the same?
I can answer that generically, and then I'll hand it over to you guys for specifics that are product. As a general rule, if you're using just standard hardware RAID, most of those products that are out on the market now, the ones that we all probably, there's always a possibility to have what we call bit rot. Is everybody familiar with what happens over time? And the only true way to really maintain your data integrity, in my opinion, is to be checking it all the time. If you're talking about a long-term archive, you need to be checking it. Checking it once is not enough, because these things deteriorate over time to the point about the zip drive, right? Have you checked it lately? So unless you're checking integrity, unless it's part of the regimen of whatever the software stack, whether it's cloud, whether it's on-prem, the value in checking that media, because it's going to be stored somewhere as rust particles stuck to something. So you need to be checking that all the time. That's my personal belief, and that's kind of our philosophy. But yes,
bit rot. Yeah.
It'll be my next band name.
It happens, and no matter what storage you're using, there are data errors creeping into it. Okay, if you're using cloud storage, there are data errors creeping into that. You're simply trusting your cloud storage provider to detect those errors and correct them for you. For us, we will store MD5 hashes, SHA hashes, using whichever one you want. MD5 is generally much faster, and we'll check the integrity of individual files. If you want us to go through the entire library and check those at either each access or in a systematic way to check to make sure that they're there, compare them against the backups and deal with things, we can do that. But that's not enough. You need to be looking at the bit error rate coming off of your storage itself. Okay, when we deal with tape, we're looking at bit error rates coming off individual drives. If we're looking at RAID arrays, we're trying to get some information there on the bit error rates there. A caution: one of the problems with cloud storage is you don't have any visibility into that. You are simply trusting the cloud storage vendor to provide error-free stuff. When you give them the ticket, you're going to get exactly the file back. You as a customer need to be keeping track of those hashes, so when you get the file back, you compare the hash to make sure that they haven't screwed the file up for you.
And if you're adding encryption onto that, you need to be even extra careful.
Yes.
I got a quick question, and I do have 3 more in the queue. I've recently been introduced to Amazon Glacier, and I'm sure all the cloud providers will be having their version of long-term, lower-cost storage. So I'd just like to get an opinion from all 3 of you about that versus the typical, like an S3 storage.
When we do costing and models for news customers, we don't do any pricing for anything other than Glacier and Glacier class storage, either from Amazon or from other people, because using the higher S3 models, it's simply too expensive for most of the news operations. So that's the way we look at it. Now you have to factor into that. For a news environment, in most environments, you need to do the expedited restores. So that means you're getting time to first byte off of when you retrieve a file measured in seconds rather than minutes or hours. So that does cost more. If you're constantly retrieving stuff from the cloud and your volume is very high, paying for those expedited restores becomes very expensive.
Yeah, from the comprise side, we can write to Glacier as a target, obviously. We can also do some tiering in the cloud, so we can write to S3 first, and then after a number of days automatically move from S3 to S3 infrequent access, which is a little bit cheaper. And if it sits there without getting touched further for a number of days, we can move to Glacier. So really Glacier behind the scenes is tape, right? So it's just going to be, as an organization, are you okay with waiting potentially hours for the file to actually rehydrate? So we're supportive of that, yeah.
So just total agreement with you 2 guys on that. We recommend Glacier for a lot of our hybrid workflows, and some that are not hybrid. It makes sense. We haven't found anything else that's at that price point, especially for assets where you've had them on-prem and you basically know that there's probably a 99% probability that you're never going to need to pull these back. Glacier makes a lot of sense financially. It really does.
I had a question about compression. So each product, if you will store data in their own file format that also has certain compression ratio to it. I'm just wondering, as far as for future goes, how do you keep track of that compression? Sort of like how a zip file compresses multiple files into one, and then you have the hash from that. And then, as far as over time, would you guys be your company would it be able to improve upon that compression that's basically already there? So to go to a customer in 10 years and say, hey, you've been with us for 10 years, your data X amount has just decreased by 30% because we were able to improve our compression ratio. There's nothing to do on your side, but you know what I mean? Just to sort of like future-proof everything.
The vast majority of content that are stored in our systems in terms of size of files, in terms of numbers of bytes, is media, which is already compressed. Okay, we'd have to retranscode, which I wouldn't really call compression at this point at the data level. So we don't turn it on LTO drives. We don't use those options in other places. If somebody wants to compress metadata, which makes sense, and you want to put that in an AXF file, then you can do that, and you can specify the format inside the file so you know how to track it down later on. That can be gflate or whatever flavor of compression you want to put in to handle that.
So I have a quick question for the three of you guys and just a quick follow-up, but I'm curious what each of your opinions is. It's a little bit of a quiz. The longest term human storage medium in human history. I'm curious what each of the three of you would say.
The longest what?
The longest term storage medium in human history to date.
It's stone tablets, right?
Any other shots at that?
DNA.
It's a good one, but I mean more of a human created, but that is actually
if
right.
you're going with human created, I would say that as far as we're talking about, we're media professionals, most of us in here. I would say that the only thing I consider a true 100-year archive that's been proven to me is film.
So I meant literally over thousands of years. The answer is actually the oral tradition. The oral tradition lasted possibly even up to tens of thousands of years.
With lossy compression.
Yes.
No,
Yes.
in fact, they think it's highly reliable even over the course of thousands of years. And there's a point I'm trying to make here. I have been admittedly a little frustrated with the dialogue today, and I think it's because SMPTE, and maybe it's the engineer's mind, wants to go to building, maybe it's because we're all men and we're trying to have babies through our technology or something, but we want to build this perfect thing, like maybe it's AXF. You know, what's our way of solving the problem of 400,000 formats? 400,001. And you know, I'm very active in the archive community.
AXF is not a format; it's a wrapper.
Okay, they're all formats. Okay, it's a wrapper. TAR is a format and a wrapper. But the point is that I think we're paying attention to the wrong thing here. The thing that we hold on to is inherently going to be somewhat transitory or extremely transitory. Process is what archivists really look at trying to maintain over longer periods of time than a particular format. An archive is permanently going to be eating its own tail in terms of the formats it's stored on, the formats of the data. And I think there's a whole other level of dialogue I would encourage in the SMPTE engineering community to also extend this conversation to the processes that we encode into our organizations to preserve this material for potentially thousands of years. And it's not a magic format, because none have been created to date that have done that well. Just a thought.
I respect that, but let's look at the converse of that too. Let's say that we know that processes are going to change, and I think, you know, we look at any of our businesses right now, we know the business's processes change radically, but having basically immutable data and content that can survive process changes is what many of the archivists are telling us now.
For me, I'm a pragmatist. I am an engineer. I think like an engineer. So if you come to me with a problem and I can use technology that's available from wherever I can get it to solve that problem now and solve it within your budget, that's what I'm going to do. I do appreciate the bigger thinking, philosophic point of views, but you know, that is not my strong point, so I'm probably not going to answer that one. But I will say that as far as the oral tradition, after this meeting, after a few beers, it becomes even more lossy.
So, Mike, before I go home and inspect my 8-inch floppies for bit rot, got me all worried about that now. Just in terms of your business analysis, obviously one of the potential benefits of having your stuff parked up in the cloud is that may eventually, it increasingly is going to be the point from which you distribute. Does that factor into your analysis? Because obviously if you're going to have to put it up there at some point or some percentage of it, it's got to affect that math a little, no?
It affects it a lot, and these are very simple business models. We have one customer that needs to get large amounts of data from their library out to individual customers who are connected to the internet each day. And the only way they can get the bandwidth to do that is by putting the content in the cloud, okay? Because LTO drives in their existing LTO library are not going to do it. If they want to put in spinning disk storage locally, they're going to have to pay for the bandwidth up to the cloud anyway. So it makes all sorts of sense to go for the more expensive storage in the cloud, so they're effectively paying for bandwidth even though they're getting a bill for storage.
All right, we're going to take one more question, and then we're going to wrap up the official meeting.
Yeah, I may be off topic, but I shoot it anyway. Because how do you guys hold hands with your clients if your clients are now acquiring media in 8K and 4K, where it seems that even on-prem or our cloud, they're both expensive. So how do you hold hands with them and explain to them that
if somebody's doing 4K and 8K, I don't hold their hands. I give them a big hug.
yeah, but you have to say at some point that you have to stop doing this because you're not going to save it anyway.
Well, I think it's important to sit down, and I think we all agree with this. We need to sit down to the customers and actually understand what their workflows are in order to better talk with them about what the relative costs and performance are of the different types of storage that they might want to use. In the end, it's the customer's decision about what storage they want to use. Our job is to handle the management of that.
Yeah, and when it comes to the archive, the value of the archive, if you're talking about the immediate archive, not the long term, what a simple question that you can pose to your organization or any organization is, what's the cost to your business if you've only got one copy of this file or two copies on some spinning disks in your organization? If something happens to your facility and you have to, is this data that you can easily recreate? Can you go acquire it somewhere else? What's the cost to your business if you don't have that data? The answer to that question tells you what the next set of questions are.
Three things that you need to know, and we will ask customers. How much data do you have?
Yep.
How much do you think it's worth? And how long are you going to keep it?
So
if you can't answer those three questions, you need to do some homework or you'll be in trouble.
I have a panelist question because I get the feeling that we're asking the same question all the time. How many times do you ask the question of how much data you have? How many times either they do not know, they brought you in from me, they have no clue it's their facility, or they're completely wrong.
Yep.
Once you
right, very much.
All right, I think that pretty well sums up. Thank you, guys. Actually, Brent, don't go too far. Don't go too far. Rose,
Okay.
come on in here. Rose needs a little credit too. She put together our wonderful refreshments outside, and we have a gift for. We have a gift for each. Do you want to?
No,
okay.
you're in there for the picture.
Yep. Okay. We have a little plaque for each of you. Here you go. With gratitude from SMPTE.
Thank you.
All right. Thank you, everybody, for coming. We'll see you in May.